I am Dr. Ashok Nayak. I am from EC department, working as associate professor in the department of ECE. Today I am going to discuss about image enhancement by spatial domain and frequency domain. Why we are going to image enhancement? Enhancement nothing but some modification on digital image. Actually, basically, image is defined as two-dimensional function which having x-axis and y-axis. In this two-axis corner pointer is having pixel. So each coordinate having pixel value, which is nothing but some grayscale value. So the particular point enhancement on particular point or particular image. When we are processing in particular pixels in the image, which call as point processing. Suppose, for example, we want to change and modification on total image, which is called as frequency domain, image enhancement by frequency domain. So, which in the topic of image enhancement by frequency domain, image enhancement by spatial domain, which point wise we can define now individually. So the aim of image enhancement is to improve the visual appearance of an image or to provide a better transform representation for future automated image processing. And image like medical images, satellite images, aerial images, and in real time photograph images. So, which all are to improve vision for better perception. And it is necessary to enhance the contrast and remove the noise to increase image quality. If some blurred images are there, some noisy images are there, in that what required object in the image we can't identify for that particular object. So at a time it required to remove noise and remove blur. So without a blur remove and without remove noise, we can't identify image object. So particular identify object or to improve better quality, for that purpose required image enhancement. So we have two types already discussed earlier, image enhancement by spatial domain and image enhancement by frequency domain. Suppose, for example, image processing is filterization of 2D signals. So having image, input image and output image, in that processing having point processing and image enhancement processing. For input is input image processing by point or particular pixel wise. You can manipulate on particular point, which is get a output image, then which is called as point processing operation on particular image. As similar, image enhancement by frequency domain, which is direct manipulate on total image, which processing to all pixels of image. So which operation gives a output. So then it is also called as image enhancement by frequency domain. So in that enhancement by point processing S equal to T of R. R represents and denotes the pixel intensity before processing, and S denotes representation is after processing of particular pixel. So T represents here transformation. Here equation is S equal to T of R. So this transformation to input of particular pixel only. So S represents nothing but a transformation of input pixel value. So if want to modify on particular pixels, suppose we want to image here 3 by 3 size image. So in this particular 3 rows and 3 columns, 3 rows and 3 columns, 3 by 3 size matrix representation, 3 rows and 3 columns, which is I want to change any first row and first column, which represents f of 0, 0. I want to need to change some modification on f of 0, 0 coordinate pixel value. Here before value having here 1. Then I want to processing on particular f of 0, 0 coordinate pixel value. Then how far I want to require to change this particular coordinate value with multiply with 5. Then 5 into 1 coordinate f of 0, 0 coordinate. So here for example first pixel coordinate when output of this point processing is first intensity pixel value 5, remaining as usual coordinate values are same, but what changes here, this 5 before value before processing intensity value for coordinate f of 0, 0 is 1, after processing f of 0, 0 coordinate value 5, because before processing 1, after processing 5, output same can replace is same coordinate. Then so which type of is processing are called point processing. So which is summarize all processing that can be done based in single image pixel. The output of process is a single value only. I give an example before, 3 by 3 size of image before processing, after processing, and we can get a before processing input image, after processing output image, which is given clearly expand you, and process carried out only pixel wise only. Example, a number of examples are given in the lecture also. For one basic example is just explained, and in that two broad categories are there, spatial domain methods and frequency domain methods are there for in the image enhancement by frequency domain and spatial domain. The spatial domain methods are operate directly on pixels, and which operation deals with pixel intensity value individually. So here other example very clearly explain you, anywhere you can take 3 by 3 size of part you can consider here, and we considered in this image x is axis, y is axis, this is a particular coordinate x and y in between having origin, but here consider some row and some column which represented here x comma y is particular pixel coordinate, and here consider also 3 by 3 size part. previously I explained only 3 by 3 size image. Here also 3 by 3 size image, and where that coordinate we can consider as f of 0, 0. Here you can consider as x comma y is particular coordinate. So here f of x comma y is represents what input image. Here input image f of x comma y represents input image, and g of x comma y represents output image, but t represents only a transformation of image, means segmentation part. So here also some part size 3 by 3 size part of image is transformation with manipulate of values, intensity values, then we can get a g of x comma y output. So here some basic intensity the scale transformation functions. So the three basic functions used to frequently for image enhancement, linear functions, and in that linear transformation and having sub types, negative transformation, identity transformation, and second one is logarithmic functions. In the subparts, log transformation, inverse log transformation, and third one is power law functions. In that sub types, nth power transformation, nth root transformation. So here having two axes, x axis represents output gray level values and x axis represents input gray level values. Their output gray level and other one is input gray level. Input gray level represents with R before transforming. And here output gray level value represents S. And here relation between only S and R only. R is represent before processing, S represent after processing, and we want to, our function, our objective is to enhance or to change any modification on only R value only. So here in that particular R function, changing some modification on particular value having three types: linear function and logarithm function and power law function. These three types. In that three types having subtypes are there. In the linear having negative and identity, and logarithmic function having log and inverse log transformation. Here two types. And in that power law function also having two types, subtypes: nth power and nth root transformation. So here graph is observing here what value here, R value here 0, output also 0 for these three functions: linear, logarithmic and power law. So here when R equal to 0, S equal to 0 in three functions. So for example here having linear function, when linear you can observe when R equal to 0 and S equal to 0. In the linear, S equal to L by 4 and R equal to S by L by 0, L by 4, and similar, and S equal to L by 4 when linearity. For example, R equal to L by 2 and S equal to also L by 2 when in the linear function. Suppose in that negative linear function observe. For example, R equal to 0, S equal to L minus 1, starting from L minus 1. linearly decreasing in the negative mode. So here L equal to L by 4 is R value and S value also a sum 3L by 4 means reversely can down fall started. For example, in the image point of view, you can represent image having pure black image in the linear transformation, linear identity transformation. Suppose when same this black image negative transformation can get a output of this is pure white image because this is negative version is different, positive and negative. Like in the positive sense we can black white, negative sense white image, so quite opposite. So here similar also the linear function having two subtypes, negative transformation and identity transformation. In the identity transformation nothing but positive way, negative transformation is negative way. You can pure black image, input image, when we can get after transformation in the negative apply function applied to that input image, then get a white image. So here these are very three gray level transformation functions. As similar logarithmic also, in the logarithmic having log values also, input R values and output S values. Log is in that some this variation is increasing and inverse log is some decreasing graph. So here in the power law function also having two types, subtypes, nth power and nth root. So here one is up nth root here and one is nth power is down. But in that identity and negative is reference for these functions, all functions. So gray level transformation when dark is here R value and output is light. A similar graph also there. In gray level transformation is in theoretical point of view, original image is here some object having some little black image. In that negative image having output of this gray level transformation, some object is identified but some black is converted to white. But in that both images, input images and output images can identified by some object, but in that no loss and not appearance disturbed for both images. But when transformation is some changes, means some here identified some reduce noise. So other point is histogram. Histogram according to image intensity values we can represented histogram values. Here one example we can consider the intensity or brightness of image shows histogram how many times particular gray level intensity appearance in the image. For example, you can consider here four rows and 5 columns. When represent 4 is represent first value what you written here, represented in image rows, 4 rows and 5 columns. In that 4 5s are 20 intensity values are there available in this image. So here intensity having first coordinate, second coordinate, third coordinate, fourth coordinate, fifth coordinate. Similar here second one f of 1, 0, 1 comma 1, like that representation we know already, basic concept of representation image. So here 0 is one intensity value. How many times it repeated? Same value. 1, 2, 3, 4, 5. 0 is repeated 5 times. Here histogram representation, x axis is intensity values, y axis how many times repeated, which represents n suffix k, how many times repeated, number of times repeated. And here r is intensity value, image intensity value. Nk is how many times repeated in same image. So here 0 is repeated 5 times. According to 5, we can color given here, yellow color given here. And 1 is how many times? Another intensity value, what value you can identify? 1. How many times? 1, 2, 3, 4, 5, 6 times. 1 is repeated in the same image 6 times. So we can, this 1 intensity value up to color mark is 6. So here 3 is not available. 3 intensity 3 is not available in image. Next you can check it 4. Means 3 here no need to give color, because you cannot intensity value available in our taken image. If 4, you can check 4. If available, you can count. If not, you can not given to color. Now we can go for 4. 4 intensity value 4. How many times? 1, 2, 3, and 4. These 4 value repeated 3 times. So you can given here up to 3 mark color. So here this is one way to representation histogram with color. And other example we can consider only bar chart. Bar chart or line representation with how many times repeated. Here other example we can consider here 4 by 4 image. 4 by 4 means 16 intensity values are available in 4 by 4 size image, in that each pixel having some coordinate and which particular value, intensity value, how many times repeated, which is representation, and x-axis representation, some intensity value, and y-axis represents how many times repeated, which is according to that we can represent. For example, here 1 is no value there. 2, you can check it 2 in the image. How many times? 1 time, 2 time, 3 time, 4 time, 5 time, 6 time, up to 6 times repeated. So you can go, you can take here in the x-axis r equal to 2 and up to how many times repeated, you can give line mark up to 6. So similar we can representation in that histogram enhancement. If we want to consider here r equal to 2 value times repeated, how many times, probability also you can count how many times this probability 2, which representation p of r of k equal to how many times repeated by this value, intensity value. So which is how many times this probability. Total all pixels of probability equal to 1. So which is also a repeated times. So here image enhancement by in the spatial domain and logic operations also there, not and or XOR. These logic operations on particular images also, not image nothing but if representation pure white image there, not pure black. This is negative also, which is equivalent to negative. And A and B which is intersection part is in the A and which intersection part of B. They're both can having representation like white mark. Remaining all are same. The A or B. A or B is nothing but A union B. A can consider, B consider, and union. What having up to representation like that. And X are input images. A is like that image, B is like that. So here X or B representation only which identified part is you can consider as like black. So here and image, XR image representation in the and representation mark is white, here mark is black. But here relationship between A and B and XR B, which is representation, little difference is there. So according to that, we can representation, also image enhancement. So other way, frequency domain also a having total image multiplied with 2. For example, image having 1, 2, 3 and 1, 0, 1, 1, 1, 1. For example, you can consider as input image 3 by 3 size. Total in the frequency domain, one example I given you now, and then multiplied with this 2 value. So output of we can representation value 2 into 1 2, 2 into 2 4, 2 into 3 6, 2 into 1 2, 2 into 0 0, and 2 into 1 2, 2 into 1 1, and 2 into 1 1, 2 into 1 1. This is considered as a frequency domain output image. So here representation only a total image multiply with any scaling value. So this is my digital image processing ICT video lecture 2. And next you can go for image restoration, and previous explained image fundamentals, how take an image and how processing, how neighborhood images, and like that we can previous class explained. Now explain image enhancement by frequency domain and spatial domain. Next class we can go for image restoration. How you can image enhancement image, process image, how can restore the images. So we can go for give next classes. Thank you for giving this opportunity.